Hello, everyone, and welcome to today's SANS webcast, Pivotal Platform, Getting Started with Native Runtime Protection for PAS, sponsored by Aqua Security. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speakers are Dave Shackelford, SANS Analyst and CEO of Voodoo Security, and Brian Morrow of Aqua Security. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to turn the webcast over to Dave.
All right, thanks, Carol, and thanks everybody for joining us today. I think the title of this presentation probably gives everybody a pretty strong sense of what's going to be discussed here. And really, I think Brian's got a lot of really interesting and compelling things to talk about with a fairly significant security advancement for the Pivotal platform. And I think, really, I'd like to give a bit of an introduction because I've been spending the past 10 years of my career focused very heavily on hybrid cloud infrastructure and people that are, really trying to integrate what they've built on premise with, highly converged environments to public cloud and make things work together. And there's been so many significant shifts in the landscape of the technology stacks out there in the past couple of years that, it's almost really difficult to keep up. And I found that security has definitely been in that position in terms of not just the knowledge needed to understand half this technology, but also a lot of the tooling that we've largely relied on in the past, let's say 15 to 20 years in various categories, from vulnerability scanning to sort of host security, across the gamut, has really not kept up in many cases. We found that some of the traditional types of vendors and traditional types of tools have not really made that jump forward, or certainly haven't made the jump forward as much as needed to really accommodate for this, sort of complex, highly converged infrastructure that we're dealing with. And really that whole notion of moving into cloud, and especially with hybrid cloud. And so I always ask the question, well, where's InfoSec, right? Where's the security sort of capability sets, and how do we start getting those more embedded and involved? And we've got to really start changing the way we work with operations and the business, because they're moving ahead. These folks are definitely building infrastructure to support cloud-oriented initiatives. And again, in that sort of hybrid model that most large enterprises are embracing, one of the things we're seeing is this significant move towards something I think many of you have probably heard called DevSecOps or SecDevOps. That's not really the point of this talk, but it's really the convergence of not just the technology stacks, but some of the roles and responsibilities that go along with that. So let's go on ahead to the next slide. And what we're finding here is that there's, sort of this traditional model, traditional data center sort of mindset, right? Where, I'm sure you've all heard a lot of the classic analogies in the security industry, tying to things like, the castles and, the crunchy shell around the perimeter, and then you get inside. Well, that is sort of the traditional data center model. Now, here, and I'm certainly not trying to call out VMware. VMware actually has been, validated with the Aqua Security tooling. So, if you've got VMware within your environment and you've built things, particularly on the enterprise PKS for VMware, that's awesome, right? You're covered here too. And, again, Brian's going to get into some of that interesting discussion. But the thing is, people that have had highly converged VMware types of environments have found that they tend to sprawl out at some point. So people take, sort of that traditional data center model with highly virtualized infrastructure, lots of storage and so forth, and they're shifting away from that more towards a newer model. And let's go to the next slide. And what this will show you is really just sort of that overall stack of technologies starting to come together, and people are looking for ways to link that together. And so here, what you see, of course, and I just threw a bunch of stuff together, right? So I don't even mind telling you guys, when I was putting this together, I was sort of laughing, just going, okay, I'm just going to put a bunch of different cloud things on this slide and see what sticks. But to be fair, what we are seeing is the need to integrate. And so whether it's this, sort of massive scale multi-cloud type of deployment, or whether it's just your internal infrastructure that you're trying to link in some fashion to, say, Google or Microsoft or Amazon or, IBM or Oracle or whoever the, cloud providers are that you're trying to build into and integrate into, the fact is we have a lot of technology now. And what you're finding security teams are, certainly discovering is that they're really not keeping pace. And so if you've been using traditional types of host security tools, many of them may not really be well adapted to things like the Pivotal platform or things like, highly converged VMware environments, or certainly not the more public cloud environments. There may be some significant performance ramifications. They may not really have any native API integration or tie-ins. And so you're really taking something that was built for a different technology stack and sort of trying to duct tape it into environments that really aren't intended to operate that way. And I've seen this consistently happening over and over again. So that's one big problem that I think tends to crop up. Another major issue that really arises here is just the knowledge gap. A lot of security teams that I've worked with just don't have a good grasp on some of these converged technologies that include things like containers and some sort of like Docker environment, certainly not, sort of the highly converged types of hybrid cloud technologies like Pivotal and, again, the VMware integrations with that. But moving from there into completely software-defined environments in places like AWS, there's just so many things that have to be understood. And we're starting to see completely new tools used for things like orchestration and automation of deployments, configuration management through the use of things like Puppet or Chef or Ansible, doing different types of build deployment models using tools like Jenkins and others. I mean, the list goes on. And certainly I could have just come up with about 50 more icons of various technologies that I tend to run into frequently and sort of lump them together here. But that really wasn't the point. It's just the fact that anybody that tells you, number one, that it's all getting much, much simpler, probably doesn't have a good grasp on some of the technologies that are being integrated in, and making them all work together can really be a significant headache for a lot of teams. So let's go on to the next slide. And one of the things that I want to talk about briefly here is just the whole concept of containers and container security. And I've given lots of talks about this, and I think certainly there's more content starting to come into the market and into the community about the whole idea of containers. But I still find that many security teams and security professionals aren't well versed in, number one, really what container technology is, and number two, where the different security focal areas should be for container technology. And by the way, I'm not doing any of that justice with this particular slide. I just sort of picked some things that I want to highlight and point out. But I think the first thing that people need to understand is that containers operate very differently from traditional virtual machine infrastructure. And so a container is essentially a modified kernel of an operating system that's capable of hosting the containers with applications and sort of binaries and libraries and so forth. But it's a shared OS versus traditional virtual machines where you have a hypervisor and then you have a replicated OS per virtual machine. Well, you can run containers in virtual machines, so you can, sort of layer those stacks together. But what that means is that you have sort of this host system that things are spun up on top of that usually, relies on some sort of traditional OS. In a lot of cases, it's variants of Linux. But that needs to be secured, number one, because if the host is compromised, hypothetically, any containers on top of that may be suspect or potentially no longer trusted either. So that's, number one. Number two, you've now got containers that are being deployed in much more rapid fire fashion, which changes just the trajectory of security. We're not used to things being spun up and down as fast as they are now. And that means that we've got to have some integration with, again, proper tooling to the images that are being leveraged for the container deployments in the first place. And so obviously I could wax on philosophically about the need to embed security controls into those images. And you should. I mean, we should have some standards and be building that into our practices. But assuming that you've got the image built in some way, well, it needs to be stored in a place or stored in a way that security has access to, again, through the use of integrated tooling. And so we need labeling systems, essentially metadata sort of tagging models that allow us to track which images are being used for deployment and the versions of those so that we know which ones are current and accepted as far as our standards are concerned. Well, a lot of the different types of scanning tools and different security tools we've relied on don't even have the means to sort of grasp that, and that notion of image provenance and ensuring that there's a labeling system that ties back to us tracking what's in use. So you need to ensure, number one, that that's being done. We need to have scanning for the images themselves to ensure they don't have vulnerabilities, because there are, in fact, ways for attacks that are talking, attackers that are talking to runtime containers, again, stuff that's sitting there running, to potentially exploit those and bounce down into the operating system that's underneath. Now, again, there's a lot more to say about that, and those sort of attack techniques and models could easily consume a much longer talk, but image scanning needs to be automatically done. So when somebody checks in a new image, it immediately gets scanned to assess it against some sort of best practices, looking for different vulnerabilities that could potentially be there and exposed should those containers be operated. And the third piece here naturally is all about runtime security, meaning once the container is up and active, you still need to monitor for malicious behaviors or indicators of malware infections or other things that might be happening in the environment. So, those are all the different areas that I think most security teams grasp intrinsically. I don't think any of those concepts are particularly challenging for most of you that are out there hanging out with us today. The bigger challenge is, how in the world do I get that stuff integrated in a way that's unobtrusive for the development and DevOps teams that are trying to do this? And number two, still give us the security capabilities and reporting that we need to be able to meet our own, sort of internal or compliance requirements. So there's a lot to tackle here. And I think containers sit right at the heart, and various forms of container technology sit right at the heart of how many of these hybrid cloud deployments are getting done. Let's go on to the next slide. And this sort of ties back to, I guess I'll call it a theme in the industry today, where, we're really finding that you have to have some degree of automation. It doesn't mean you need to automate everything you do. In some cases, that might, in fact, lead to some adverse conditions or scenarios. So you really don't want to just assume that everything should be automated. But there's definitely got to be more automation than we've had in the past. And if you go back to the entire spectrum of a DevOps pipeline, and make no bones about it, the driving business factor in a hybrid cloud implementation is software development and deployment. And so, you have to sort of bring that into the discussion pretty much anytime you get into these discussions. But, you got to have code scanning. So, and it's got to be automated. So especially in a CI/CD pipeline where you have legitimate continuous integration of development streams, every time somebody's checking in code, you've got to have something there that can assess that code in real time, ideally, versus having that traditional old school model of development where, really you had sort of phased check-ins that would allow for a bit more time to plan for scanning and implement scanning. No, we've got to have stuff that's integrated now because the code is constantly being, branched in. You need automated app scanning in the test and staging phases. You've got to have checks for your own standards across the spectrum of this. So this is not only the servers or the builds, right, but the container images and even the software-defined networking configurations that are in place to facilitate numerous containers being able to talk to one another. And all this stuff, again, is very converged. And that means the tools that we're using also need to be converged at the same time to see these things as they're happening, monitoring of all the components within that deployment pipeline. And then the last piece, and this is a big one, certainly for security teams, is the ability to actually get evidence and indicators of compromise and forensic artifacts out of these converged hybrid cloud environments that have really felt like black boxes in some ways over the past several years. You know, we need that capability to pull forensics out, perform investigations, because you're not going to just ignore that technology and say, well, it's moving so fast, you know, we'll just let it go. Well, bad things can happen in pretty, rapid fashion too. And so you want to make sure that if that does occur, we do have a need to perform some sort of analysis and investigation. We've got tools in there that can help us do so. And so again, this is, all I think coming back to a theme of better tools, different tools, things that have actually been built for these types of deployments. Let's go on to the next slide. And this really sort of wraps up my introduction to the topic at hand. And, really what I want to sort of finish up with is this thought process that we've got to start adopting, where, again, you don't necessarily have to call it DevSecOps, if you don't want to. That's sort of let's call it a mantra or maybe a philosophy in the world of development today that is, in fact, gaining a lot of traction. And I've come sort of full circle around to this to believe personally that it is the right model, not only for development, but for security capabilities. As long as we're enabled and cognizant of what's being done, we have lots more opportunity to really embed ourselves into those pipelines. But in order to get there and in order to do it well, we really need more automation as a theme as well as a set of tools. We need full integration into the containers and workloads that are being deployed. Again, as a theme, that's something that has to be done. You can't come in after the fact like we have in the past and say, I see you've got all this stuff running. We're actually going to do a deployment here. We need image scanning and tagging, as I was talking about. We need runtime security for things that are actually up and operational. And we need to be able to collect those artifacts for forensics and investigations. And really, we haven't seen a lot of that in the past. And, it's sort of nice to actually see newer and better tools emerging that can actually fill these roles. And so, really what I'd like to do now is hand things off to Brian Morrow, who's going to be walking us through how you can actually create policies that identify and block malicious behaviors, looking at a very, very popular technology stack in Pivotal. And this is an area that has really been a blind spot for a lot of organizations that are using this technology. It just hasn't really been something that security ever got embedded into, and that has most definitely changed. So Brian, take it away.
Brian, you're currently muted. Brian, I'm going to take away presentership for a moment and give it back to you in case you're having trouble with the control panel.
Yeah, sorry about that, guys. My GoToMeeting control panel locked up on me. Sorry about that. All right, so let me get started here. Again, apologies for that delay. And Carol, I just want to check, can you see my screen when I come back?
Yes, everything's working well, and your audio is good.
All right, thank you. So again, my name is Brian Morrow. I'm a solutions engineer with Aqua Security. And just a brief overview of what Aqua Security does is we are a cloud native security platform. So we're going to be focused on the PaaS environment today, but we also secure things like Kubernetes and functions as a service as well. So when we talk about security for Pivotal Application Service or Pivotal Cloud Foundry, Aqua takes the standpoint that we need to make sure that we're looking at the entire stack. So not just the applications as they're being built and being pushed into the blob store, but we also need to protect the apps that are running, so the runtime protection that Dave was talking about, and then the actual hosts that the applications are running on. So in Pivotal Application Services, that's called the Diego cell. So again, we need to make sure that we're securing all of these different environments, and then for those environments, we need to apply risk-based policies to prevent unapproved droplets. So basically, the application code from being deployed onto your environment. So if you think back to Dave talking about the scanning during the CI/CD process, well, say you have a pipeline job where you're scanning your application with Aqua during that build phase. Aqua can actually tell the CI/CD solution to prevent that from ever moving on during the step. And then we can also once it gets into when you do a CF push, which I'm actually going to show in a demonstration a little later, you can actually block it as it's trying to be pushed to an application on the Diego cell. So again, we have multiple phases of protection. So again, if you think of the shift left, blocking it at the developer's point of view, before it becomes an application, and then the runtime protection when it's actually an application. And with that runtime protection from an executable configuration standpoint, we can also control network connectivity. So again, trying to, the entire life cycle of the application, and then, once it becomes a running application, to make sure that, we can protect against, attacks. To talk a little bit about how the Aqua deployment works. So you're going to see a little bit of a busy architecture slide, but it kind of does a good job of breaking down exactly where Aqua fits into, the PaaS environment. So I'll point out kind of on the bottom blue level here, you'll see that these are the different kind of feature functionalities of the Aqua protection. So the scanning of the app, app assurance. So assurance is what we call, is an application compliant or non-compliant with our security policies? If it is compliant, it allows it to continue, and if it is not compliant, it blocks it. So that's what we consider assurance. And then as we move on to the runtime protection, that's where it's going to be the Diego cell security, the app runtime protection, the network discovery, and then the microservices firewall. So that's basically a layer 3, layer 4 application specific firewall. So again, you can start to apply firewall policies as close to the source as possible, which would be the application instance itself. So this isn't like if you're familiar with Kubernetes or things of that nature, it's not a CNI, it's not a networking interface, or a service mesh or anything of that nature. It's actually blocking connectivity at the application instance. So again, you can prevent inbound and outbound from within the same cluster, or it's also ingress and egress traffic from outside, the internet or outside networks. So again, making sure that we can protect that entire application. And to talk a little bit about, where, again, we actually scan from a point of view. So you'll see here the developer, they do an application push to the Cloud Foundry API. And so right here, Aqua is going to determine the application assurance. So is it compliant or is it non-compliant with our security policies? And if it is, it moves on and pushes it into the blob store, which is basically an application repository. And then we're going to, just because an application is compliant during the build phase or during the application push phase, that doesn't mean that it's going to continue to stay compliant over time. So Aqua needs to provide the ability to continuously scan applications in the blob store or an image registry for compliancy. So that's kind of where you see that, we have this app scanning line that points into the blob store. So, on a daily basis, you can go out and scan already existing images for new vulnerabilities. And then as we kind of transition from the assurance phase into the runtime phase, that's where we can actually determine, okay, is this image that's already in your blob store compliant or non-compliant? And if it is, do we want to allow it to run? Or if it's not, we want to prevent it from running. So again, that's kind of that the very start of the runtime protection. And then the final piece of that is when it does become an application instance, we need to make sure that we can do runtime protection. And in my demonstration, I'll show a little later that where we can actually block executables and prevent new files from executing and things of that nature with our runtime protection. So just to give a little more detail about the actual application scanning and what we're looking for from a vulnerability standpoint. So we have, multiple different sources of vulnerability information, vendor advisories, Red Hat, Microsoft, etc. Our own commercial database. We have an internal research team that also supports, as a source, and then the NVD advisories. So again, we have, 6 or 7 different sources where we're basically building a composite list of all these vulnerabilities, checking the status of those, comparing the severity scoring, and determining what the appropriate risk score would be for that vulnerability in your environment. Hard-coded secrets. So think of these as like private RSA keys, certificates, things of that nature that shouldn't be left inside of an image. So we're looking for those. Excuse me. Malware. So, standard malware checking. Configuration issues. Is your application running as root? Does it have too many privileges? Is it using the correct user account? So things of that nature. And then, if you're in an environment where you actually have open source license restrictions, we can determine compliance off of what licenses your open source packages are actually using. So once we have that list of things we're scanning, again, we mentioned scanning in the CI/CD or as it moves into the blob store, and then just kind of a view, and I'll go through a little bit some of these views in the demonstration, but you can view CVEs by severity, resource type, where it fits into the application. From a developer's point of view, if you think of Dave's mentioning of shifting left and getting the developers more involved in the development, in the security lifecycle, we can provide within the CI/CD tool, metadata related to the vulnerability and give them information on how to fix that. So if there is a fixed version available, provide that fix to the developer and they can make a quick change. So again, you're putting some of the security responsibility in the hands of the developer, so it can happen closer to the development of the application, and then it's a quicker turnaround most of the time. And then the ability to actually acknowledge vulnerabilities and give a grace period for a fix. So say you have an application that has a specific vulnerability that there's no fix for, but you need to allow that critical or high vulnerability into your application for say 15 days or whatever to give the developer time to get that fixed. So you can actually acknowledge a vulnerability and say, okay, and then after 15 days, expire this rule, and it's going to go back to being non-compliant again. So the flexibility to, again, give yourself a grace period to, okay, we know this is a vulnerability, but we have to have this particular vulnerability to run. Again, we want to make sure that we provide that flexibility. Now to talk about the policies that actually control that assurance. So you can see on the left here, you have a lot of different controls that you can select. So look for super user, look for those sensitive data keys, look for vulnerability severity. So if you wanted to block low, medium, high, or critical, or look for malware. So say this is your default application check. You have to pass all these things to become compliant. And then you have some actions that are associated with those policies. So if it does fail, you want to make sure you create an audit message. Here's that option to actually fail the step in the CI/CD process. Mark failed images as non-compliant. So again, just a visual representation that, hey, this image does not meet our compliancy policies. And then you have some exceptions to those. So ignore vulnerabilities that or maybe been published in the last 30 days, ignore specific vulnerabilities. So again, the flexibility to build these assurance policies to match either your default all applications, or to kind of scope these out to specific applications or specific application groups. And then as we move on to the runtime protection, so again, this is when an application is actually running, what we can do to protect against that. So we need to make sure that these are flexible and they can prevent unauthorized behavior inside of those running garden containers. And then things that we include: drift prevention. So to give a little insight onto drift prevention, this is Aqua's kind of proprietary implementation of application and container immutability. So what drift prevention does is it basically says when we scan an application, we know all the executables that are living inside of that application, and we basically create like a whitelist. Say, okay, if the executable that goes to run matches one of these existing executables, we're going to allow it. But if it doesn't, then we're going to prevent it. So again, drift prevention, in essence, prevents new or modified executables from running within your application. So it doesn't prevent, creating an executable file, which I'll show later, or going out and downloading a file off the internet. But when you go to try to run that executable that didn't exist, it's going to prevent it. And then you can, again, much like the assurance policies, define multiple policies to make sure you're scoping appropriately to your applications or, to your namespaces. And on the controls list, you can see that there's a bunch of different options for, controls that you can set. And then another thing to mention is this enforcement mode at the top where you see the audit and enforce. So we need to make sure that you have the ability to learn from your applications and to build out your policies and not just start day one enforcing and blocking executables. So we have this audit mode where we send messages that say, hey, we detected that we would have blocked this. So again, it allows you to kind of learn. And if you think into your dev test environments where you just want to make sure your application can run, but you still want to see if there are any security exceptions that are happening for that application. And talking about the Diego cell protection, as you can see, doing CIS benchmark scanning against Linux benchmarks. So does it match the standard CIS benchmarks? You can also do custom benchmarking as well. So if you had specific configurations that you needed to do for your hosts, you can check for that as well. And then things like file integrity monitoring, host level authentication by users and groups, and then user activity as well. So not just protecting the applications, but the infrastructure that the applications are running on to give you that entire cloud native landscape security protection. The next feature is kind of talk a little bit about that network discovery and firewall. So again, this happens at the layer 3, layer 4 aspect of an application. So we can automatically detect and map the internal and external communication. So basically you turn on a profiler and it listens to exactly what's happening inside of that application. And you can build out something like this map that you would see, and then use this map to create your firewall rules. So, okay, this should be allowed, this shouldn't be allowed. And you can, create these rules based on service identities, which are logical services created within Aqua, DNS, or, strictly IP. And then again, as Dave mentioned, you need to be able to audit all of these events. So, if there is a blocked network activity, make sure that that's audited for, analysis, from within your security solutions. And I'll go through this in the demonstration as well. So what's the, what if you're running, PaaS and Kubernetes, and you have multiple clouds and, multiple, different providers, things of that nature. So Aqua provides a unified security across all of those environments. So we can have a single pane of glass against all those deployments. The security controls are the same regardless of the infrastructure. So, our tagline is kind of secure once and run anywhere. So once you secure it, no matter where that application runs, we're going to apply those same policies to it. And then make sure that we can, secure the migration of workloads as, people move from, say, PaaS into Kubernetes, or from PaaS into, Pivotal's PKS offering. So again, just the flexibility to make sure that those controls can shift between workloads. And today, Aqua is the only choice for securing the entire Pivotal platform. So we're the only, cloud native security tool that provides runtime protection for, Pivotal application service today. And then, just to kind of follow up on that, for the benefits of Aqua Security, just as a summary, we can detect vulnerable code and prevent its deployment, monitor, segment, and protects the app in runtime with the runtime protection and the firewall aspect. Natively scale across all your PaaS applications. We are a tile that is deployed from PivNet, so we are native to Pivotal Cloud Foundry. And then, we just talked about unifying the security controls across, Pivotal Application Service and, Kubernetes Pivotal Container Services. All right, so with that, I'm actually going to jump into a quick demonstration here real fast. I'm going to stop my slide deck real fast. So I'm going to jump into the Aqua Security solution. And what we're going to do is we're going to scan a couple of applications real fast. We're going to scan one that is that is allowed, so it matches our security policy, and then we're going to scan one that fails and kind of see the difference in what you get from an Aqua point of view. And then we'll do a little runtime protection where I show the drift prevention and the network firewalling. So with the first thing I want to do is talk a little bit about those assurance controls that we saw earlier. So you can see I have a default image policy. Here's some actions that I can take. There's that fail to step in the CI/CD process, create an audit message. And I just have a simple check. I want to just verify that no high vulnerabilities are allowed within my applications. So this is going to apply to every application, within my Pivotal Application Service environment. So now, if I click over to my terminal real fast, what I'm going to do is I'm going to deploy a simple application. So I've got just a simple hello world here, and I'm going to say, let's call this hello webinar. And so as that's building, I'm actually going to build a second one here that should fail. So hello world should be allowed, and this one should fail. Oh, forgot something here. There we go. And so now, if we take a look, so the hello world one here, you can see that Aqua is actually scanning this during the push process. We can see that Aqua Security stands status passed. There's 0 vulnerabilities, and now it's going to allow it to continue and say, okay, go ahead and build this application onto our PaaS environment. And now as we wait for the app to start, if we go take a look at our images now, you'll see that I have a hello webinar image in my Aqua repository. You can see that I have no issues. So if I go in and take a look, my image is approved. It's past my default policy. If I look, there's no vulnerabilities, there's no sensitive data, there's no malware. So none of that was detected. So that application is allowed to run. And as I transition back, you'll see that it is now running on my, and if I take a list of that, you'll see that there's my hello webinar, and it is started with 1.1 of 1. And now if I take a look at, so this guy is still running. So let's move on to the next step. So I'm actually going to connect into that hello webinar application. And this will transition us into the runtime aspect of it after this other application gets done real fast. So it should almost be done. So here we're now running to the scanning. So Aqua is going to scan this. You can see this one actually prints out the vulnerability information that Aqua provides. And you can see that it has 22 high vulnerabilities, a total of 58 vulnerabilities. And now, it failed to compile the droplet, and we failed it. So again, Aqua told Pivotal Cloud Foundry to, hey, don't allow this application to be pushed because it doesn't meet our security policy. And now if I come back to my images tab, you'll see that I have the Rails webinar. We can see that it's marked as non-compliant. It failed because of my vulnerability severity. And now if I drill into that, you can see all the information about the vulnerabilities. We mentioned earlier about the multiple sources, and in this one you can actually see where the scores actually differ between the NVD and the vendor. And so again, we're determining that the 7.5 is the appropriate score. So again, we're trying to reduce false positives, but in this case, we're actually elevating it to the higher security. Sensitive data, so we actually detected some sensitive data in this application, but because it wasn't part of our policy, we didn't fail that step. So again, making sure that you can scan these applications, determine your compliance from a central location through all of your different environments. And now if we talk about the runtime protection real fast, if we take a look at the runtime policies, I have this default runtime policy. I mentioned the audit and the enforce earlier, so we're actually in enforce mode. Here's that drift prevention. So you can see that what it says is prevent executables that are not in the original image from running, or images from running whose parameters have changed. So again, prevent new and modified executables. And then I just wanted to show like this executable blacklist here at the bottom. You can see that I'm basically denying access to the PS utility. So now if I transition back to that container or that application, you can see that I'm here in my hello world, and I can run ls. But if I go to run PS, you can see that I get permission denied, because again, I blocked the PS command in my runtime policy. So now what if I try to create a file that didn't exist? So I can do touch demo chmod x. So I'm basically turning this file into an executable, and then as I go to run that, you'll see that I get permission denied because of my policy of drift prevention. So again, it prevented a modified or new executable from running. And then, Dave mentioned a couple times about auditing these events. So here you can see that I have a file exec block on my hello world or my hello webinar image name. It tells me, what Cloud Foundry space it's in, what Diego cell it's actually running on, all the information about the user, what, permissions, all of that, what the parent process, what the resource was, what that resource digest is. We blocked it based on this security policy. So, again, monitoring and auditing of the events that are happening to your running applications. And then here is the demo attempt here. That would be the drift prevention, and you can see it's an unauthorized file locked down by runtime policy. So again, preventing things from happening inside of your applications that that are blocked by your security policy. And then real quick, as just so we can have time for questions and answers, I'll show the container firewall here real fast. So if we take a look at my hello firewall rule, you'll see that I am basically doing a simple firewall block of I'm allowing port 80 access to aquasec.com, and I'm denying access to port 80 to Google. So now if I transition back to my application and I do a curl aquasec.com, you'll see that I get access. And now if I do curl google.com, now if I go take a look at my audit log, you'll see that I now have a network connect block instead of a file exec block for that application. And now it's going to tell me I tried to run curl to Google on port 80, and we blocked it based on the hello firewall policy. So again, providing the ability to create these security controls to prevent insecure applications from being developed and pushed into your blob store or registry, and then the runtime protection of those applications as they're running to create that entire landscape security control. So that's the quick 5-minute demo of what Aqua can do from a very high level overview. And again, this can all be done on Pivotal application service as well as Kubernetes and Docker based workloads. So with that, I mean, that's all I had from my point of view. I think we'll be opening up for questions now.
All right, thanks for that great presentation. We have some questions ready for the Q&A. However, if anyone has a question for our presenters, please enter it into the questions window now. Our first question is there an audit log available that shows which Diego cells have been flagged as vulnerable or non-compliant?
The answer to that is yes. So, you can see here at the top, Aqua has some different types of alerts. So you have, just alerts where images and hosts are marked as non-compliant. So here you can see this host, this Diego cell, has been marked as non-compliant. And basically what that's saying is, hey, it failed the Linux CIS benchmark. So, if you wanted to prevent workloads from being deployed to this host, you could apply, a runtime policy and prevent that. So yes, we do audit those, and then we also audit, user account activity as well. Whether you can see here that, from an Aqua point of view, anything that I've done to when I change my firewall policies or I delete specific, all of that, all user activity, even on the Diego cells, are tracked, as well as the user account activity within the Aqua console itself.
All right, thank you. Our next question is, one, One of the slides said Aqua protects against malware. Can you explain more about this malware protection? For example, is it signature-based or does it have machine learning?
Yeah, it is signature-based. So yeah, we're basically comparing our known malware database signature versus signatures that we detect when we do the image scanning. So yeah, it is all signature-based.
All right, thank you. Our next question is, what is PKS?
Yeah, so PKS is Pivotal's container service. So it's their hosted Kubernetes environment. So Pivotal is responsible for managing the worker node or the master nodes and the worker nodes in your Kubernetes environment. So again, it's just another offering from Pivotal, whereas PAS is the based on Cloud Foundry, PKS is based on Kubernetes.
All right, well, that's all the questions we have. Do you have any closing thoughts you'd like to share?
From my point of view, I really enjoyed Dave's presentation about breaking down, the philosophies of, DevSecOps is kind of a mindset. It's not really a forced thing. We see a lot of that where, as security and ops start to work together, we find that, it kind of alleviates the problems from some of, from both organizations, the development teams and the ops teams, and then throwing security in the mix where everyone is working together to kind of work on security instead of just security being responsible for it. Now everyone kind of has a piece of the pie, and it definitely seems to be a work in progress, and things that for customers that we've seen have made a lot of progress with it. So I really enjoyed that aspect of Dave's presentation. That's all I have. Thank you, guys.
All right, well, thank you so much, Dave and Brian, for your great presentation, and to Aqua Security for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.